There you go. So what does it mean to solve by graphing? Yeah. You graph it. Where do we graph it? Yeah, we just go to Desmos. What does roots mean? We've talked about this. It really just means x-intercept, or it means zeros, right? These all mean the same thing, right? So this really means that I should go to my Desmos calculator, graphing calculator, and just type this thing in. Y equals 3x squared plus 2x minus 5. Some things that I've noticed people struggle with. Desmos, you can't plug in like a number over here. Can't plug. Why is it doing that?
You're doing two straight lines. They never come to a point.
It always
does that.
It always gives you the X point. No, it does not.
Mine, it just says, like, it just gives me, like.
Oh, mine always gives you those lines.
Well, that's just because you guys aren't using X.
It gives me the exclamation.
Anyways, my understanding until I started playing with this is that you can either have nothing, which I kind of wish it didn't. I kind of wish it forced you to say y equals, okay? But you could either have y equals or you could have nothing. You can't say equals a number and get right answers, okay? So when I made that equal to 0, I guess it still worked, but I can tell you that the state calculator, the one you get on the exam, will not, if you type in equals 0, will not solve it for you. So it says solve by graphing. Boom, there's one answer. X equals negative 1.6. Tell me what that is. Can someone tell me what's happening there? Something weird is happening there. Yeah. The 0.6 is repeating, and someone should say, wait, no, it's not, because that's a 7. What is Desmos doing? It's rounding. So this actually is negative 1.6 repeating and positive 1. Okay, so if I go back to my notes. Luke, you need a pencil? Yeah? There, my always has the pencils. No, it's the honor all the way at the end. Warmer. No, but I'm so tempted to say yes because I wanted you to dig through someone else's thing. Warmer. Yeah. Oh, you're on fire. Do you ever listen? Are you ever absent and you listen to these notes and you're like, what's going on? Buddy?
Sophia was listening to you saying you're going to throw Luke out the window.
Yeah. All right, next one. So we have different ways of solving these things on the test, which is next Monday, a week from yesterday. We have to be able to solve them the different ways. If you just give me the answers, you will lose all points. This says solve by factoring. Okay. What's our first step in factoring this?
GCF.
Pull out a GCF. What is it? 3. I kind of like pulling out the negative because I don't like my x squared to be negative, and I'm going to get x squared minus 2x plus 3. And then I'm going to x box that. Do I need a box?
No.
Did I make a mistake? Oh, my bad. Thank you. That should be a minus. Negative 3, negative 2. Is that 3 and 1 where 3 is negative? Someone the other day wanted to say, these are the answers to this problem. We have to actually factor this for 2 reasons. 1, if you don't, you're going to lose some points. And 2, you might make a mistake. The question is, when does this equal 0? This equals 0 when x equals 3 and when x equals negative 1. How many solutions should we be looking for? 2. I know a lot of you like to jump on Desmos and then graph this and check. That's I highly recommend it, but you have to show this work. Okay. on the test, if you get the right answers, but all this work is wrong, because you're like, I don't know how to do this, and you just write random stuff down, you'll get 0 points. Completing the square. I think when people get really good at completing the square, they kind of like this choice. We're trying to find the 0. So we want to know, and for completing the square, we kind of need this 0 over here. What's our first step with completing the square? Kick out the constant. We're going to end up with a c here. We can change this to x minus, you okay? Minus 4, which means that up here our c is going to be 16. So I got to do that to both sides. Some people are tempted to write plus 16 down here, but it's already in there. That plus 16 is in this. We just have to illustrate what it is up here. So then this equals 4. Yeah. Now I can square root both sides. I get square root both sides. I got to put plus or minus. So I get plus or minus square root of 4 equals x minus 4. Square root of 4 is 2. I don't know why I'm not writing over here. So we get plus or minus 2 equals x minus 4. Oh. Add 4 to both sides. 4 plus or minus 2 equals x. You would not get full credit for this. You got to finish this. 4 plus 2. 4 minus 2. Oh, I hate how I wrote that. X equals 6. X equals 2. Again, it's not a bad idea to throw that in Desmos and check it. The bad news, though, is if you check it and it's wrong, then you got to figure out where your mistake is. And then finally, the last, is this the last way? The last way, and I think I'm going to add a question on here because we need one more because it's the kind that people forget. But I want to solve this using quadratic formula. Okay, so x equals negative b plus or minus square root of b squared, no, b squared minus 4ac all over 2a. The best thing about quadratic formula, it works for everything. It doesn't care if a is negative, if it's positive, doesn't care. It's just like, boom, just throw it in there. Only thing is it's got to equal 0. And then this is the hardest one. Okay. In theory, I'm okay if you get to this point and you go straight to Desmos and you just type this ugly thing in. I know some people were struggling with that. So if I go to Desmos, I can type in 4 plus, I got to pick either I want plus or I want minus. And I actually like to, before I even start that, like to make it division. 4 plus square root. Parenthesis, negative 4 squared. Thank you. Parenthesis, negative 4. This is not my favorite way to do this.
Wait, what's the difference between finding the zeros by completing the square and this one?
I will tell you in just a second.
Will you finish the notes early? Can we listen to the song?
Sure.
I want to listen to like the people song, not the. Yo, we're not listening to that. Yeah.
Okay, so I do all this work and it gives me one of my solutions is negative 2. You want to double check that you typed everything in right. Why did I have to put this 4 in parentheses? Because it's a negative, right? So some of us don't do that. The answer should be negative 2. And you're like, wow, I thought it was a nice number. I know it's a nice number. Okay. So we get negative 2. And then to find the other answer, I got to come here and do my subtraction. And I get x equals negative 2 and x equals 1.2. So honestly, when we look at our notes, what? Oh, okay. Then I want to, or all I need to do is show this and then 2 answers. Okay.
Why don't we start in the back then?
We didn't. It was just printed weird. Maya, you had a question.
I was just wondering, like, the difference between, find the zeros by completing the square. Is that just make it equal 0?
Completing the square, what it's saying is we have to do this where we have to get a perfect square. So we have to do that trick of kicking it out and adding a C.
Okay.
If we did this by graphing, if we did this by factoring, if we did this by quadratic formula, we get the same answer. So did I answer your question?
Yeah, so
Okay.
I'm trying to figure out.
It's just a different method. And it's called completing the square because we end up with this perfect square that we can then just square root both sides.
Okay.
So I need to add one more. I should have had this on the notes. We'll call this number 5.
Little 5.
7x squared plus, no, minus 175 equals 0. What do we? So this is the type I call 1 type X. Do you remember what we do for 1 type X?
I remember learning it, but I don't remember how to do it. Don't you
So I would have said just solve this. This one we could have solved the first day. Do you have an idea? Okay, so what do we do first? What do you think?
I can't remember.
It's okay. Brody?
Can't you substitute B for 1?
No.
You add the 1 to 7.
Yeah, this is the one where we learn the first time because we solve it the same way we've solved everything. We don't think of this as an x squared. We just think of it as an x. So if that's an x, we're going to add 175 to both sides. And we're allowed to do this because there's only one type of, we're going to divide by 7 because there's only one type of x in the problem. That gives me x squared equals 25. Square root both sides. When I square root, it's plus or minus. X equals plus or minus 5. This is when we did a day of this. The next day, you thought everything was going to be, if the answer was 3, you thought the other answer would be negative 3, right? And say again. So x just equals 5 or negative 5. Okay. So because there's only one type of x here, then we can just solve this. Okay. All the other ones have an x squared and an x squared and an x. Good talk. All right, systems. When we saw these, we had this little markings on them for the system. By graphing, what was the solution to a system, or what is the solution to a system when we did them way back when? An ordered pair. So we're asking you, what is the ordered pair where what happens? Yeah. Where they intersect, okay? Fundamental theorem of algebra says the highest degree is the number of solutions you should look for. This says solved by Desmos, so I'm going to go straight to Desmos. So I go over to Desmos. So zoomed in here. Let me zoom out a little bit. And I'm going to type in y equals negative x plus 4 and y equals x squared minus 2. Okay. Where are my solutions? Where they intersect. So all I got to do is go here and here. So my answers of this problem are negative 3, 7, and 2, 2.
Is there a way to solve it without doing this?
Absolutely. I'll tell you in about 5 seconds. So Great question. How do you solve it without? So we've learned how to solve systems by elimination, substitution. Okay. We could just set these two things equal to each other and solve it. Okay. And we should still, and then you plug in your x values back in to find out what y is. Say again. Say it. You can't, elimination's probably going to be the hardest one to use here. So but you could, you could go, let me show you this method. This is the one that so actually I was working with another Algebra 2 teacher and they're like, how do you teach these ones? And I go, I just throw them into Desmos and there's a solution. She goes, this is how I show them. I go, you got to set them equal to each other. Okay. Then I got to get this equal to 0. Plus 2. Okay. And then I teach them to factor it.
Wait, wouldn't it be -6?
Oh, thank you. Then I teach them to factor it or use a quadratic formula. And then they get their x values and then they have to plug them back in. Which method do you like better? Okay. Thank you.
Oh, that's
All right, this next one.
Wait, who teaches?
Do we have to do it like that?
No.
Who teaches that?
Who teaches this method?
Yeah.
The Beulah Park teacher used to teach it this way.
We all think yeah, Beulah Park.
Ooh, that's why they're cute.
All right, let's go to this next one. So it really, in some ways, it's a matter of just typing this into the calculator. Negative x squared plus, what the heck? And then the other one is 2 minus x. Okay. And I definitely don't want that one there. Okay, so here's the thing that some people have done, and I think on this one, you're not going to miss it, but they're going to go, oh, they might not see that second solution, but there it is. There's one, and there's the other. So really, this is just a matter of plugging this in 0, 2, and 5, -3. This method is so easy to use that I could give you some craziness like I did on the next question, or the next two rather. What does that mean? I have no idea what that means, but I'm going to go to Desmos and I'm just going to type it into Desmos. So we have y equals the sin of x. Y equals 3x plus 5. It's actually sine, even though it looks like sin. And we can find the solution right there. Boom.
Mom, your phone fell out of your pocket.
Hey, I did not have that supposed to be in the chart? No. Beaver Condom says that.
That solution is negative 1.973. What is the biggest flaw? And I looked it up and I couldn't figure it out. But what's one problem with Desmos that we've had issue with this year? Yeah.
You can't really plug in like B or F, like B or like BTUK.
Right. You can't plug in K.
Doesn't show you the point. It just says 2 numbers.
Okay. Yeah. So what Luke said, which was it just shows you 2 numbers. It rounds for you. Do you remember that problem where I wanted 5 decimal places or something weird?
Solace doesn't want it rounded. Sometimes I'm like.
So let me tell you this.
It tells you beneath the question. It says round.
So on the state test, they may ask a question expecting you not to use Desmos and say don't round, and you're going to be, and Desmos automatically rounds for you. You have to do it by hand.
So there was one of my things, and it was like find all complex solutions. So it was like a positive and then a negative, and I put the negative before the positive, and I knew it was right, so I kept clicking it, and it was like correct answer, and it was the negative after the positive.
I'm actually so mad. Every time that I've done it, like say like go back to the point. Go back to the point you were talking about. Say it was negative 1.937. all you have to do really is go down on the last decimal and then put 25 instead. So it'd be negative 1.925. Or no, 725.
So that's a guess, though, right?
No, every time I've done that, it's fine.
Okay. It's still a guess, though.
Yeah.
But it worked out for you. Okay, next one. So as ugly as this next one is, all we got to do is type it in. Fundamental theorem of algebra says what? I've said it like 20 times. Not that you even have to know it, but yeah.
The highest degree is the amount of things you should look for.
Yes, so how many solutions should we look for on this one?
4.
3, yes, 3.
What are you saying? 4 divided by 2. I'm sorry.
Sometimes when people say things with a lot of confidence, you think that they might be right. Be careful, they could be totally wrong. Not to say that that happened 2 seconds ago, but
What is going on?
3, 2, 1. So the only flaw with type this in the Desmos and see what happens is we don't really know what the x third shape looks like yet. Maybe some of us do know, okay? But because we expect to look for 3 answers, boom, I've gotten 1, so I'm going to write that down. Negative 1.471, comma, negative 10.586. So I got 1 solution. We said there might be 2 more. So if I zoom out on this thing,
I saw big boy.
what makes you think that there might be another one? Nothing. I like that answer. Yeah, so is it going to come up here and then like curve back down
Yes.
It will be on the other side.
or come back down this way?
It's not coming. I think it is coming back there. You gotta keep going. Just keep going.
Okay.
Maybe
Now-
just a little more.
I was helping someone the other day and they did this and then they said, I need to go back. So then they started doing this. How can I get back quicker?
Oh,
Do the settings.
Hit the home, just hit the home button.
Oh yeah.
I could not figure out how to do that when I was doing the homework because I saw Brinley do it and I was so mad at him.
Yeah, that home button's nice.
No.
3, 2, 1.
Maybe the Y and X intercept.
Okay.
I'll be going like this for 5 minutes.
Yeah.
What's your example, Maya?
No. Maybe. All right. So I'll tell you, this little curve right here is all the curve it has. So that's one disadvantage of this is we don't know. This is really an Algebra 2 question, but I'm just trying to make the point that just throw it in the calculator and see what happens, okay? Because if you don't know, you can put it in there. Here's a trick that I want to show you from way back when. In any of these systems, you can throw in, right? So when you get a system on the state test, and it says solve by elimination, and it's a multiple choice question, what do you think I think you should do?
Wait. Eliminate.
No.
Desmos.
Put it in Desmos, right? So I have been saying like it's good practice. Now what they'll do is they'll give you a question and they'll say, where is this, what step did they make a mistake in this elimination? Then Desmos does nothing for you.
Sorry.
Just for funsies, I'm going to give the 4 of you a point.
Okay. You do.
Me? Why did you get 5? She's
That's
just
like the first time I've ever gotten it.
I know. That's why it's fun. Funsies. You asked the other day, has there ever been a class that didn't get a detention? How about this? There's been classes that didn't get a single point all year.
That's yeah.
Actually.
Yeah. I don't know if you remember this, but like on the 4th day of school, I'm like, hey, we play this game. It's called.
Yeah. It wasn't even the 4th day of school. It was like the 4th month of school. You told
Okay.
You told us really late.
Okay. This other class, I never had to tell them.
You didn't even tell them. And which
No.
class is that?
It was a first period algebra.
Oh. Okay.
And I
Yours
never
was
told
like
them.
this year.
Oh, was it last year?
It was 2 years ago, I think.
Francis?
Kid with his hand up.
Yeah. Oh yeah. Can I argue that? Oh my I was
I'm not a part of
checking.
this.
Yeah, they don't want to be part of this. So
You can argue, but you're gonna lose.
no, you can't do that again. Actually, you have to let me argue this.
I'm pretty sure.
I
You
was
wait,
checking. So like for my own health, I was checking if I was dehydrated. So I was checking that. Like that's the only reason I was doing that. Just like to make sure I wouldn't pass out right now.
Okay.
That's what I was doing.
So you now have 2 points.
So
You said at the beginning of the year we just drink water.
You can argue it.
That way, if we won, we'll lose.
Yeah.
Daddy lost.
How
I
about
lost.
we have a class vote? Should I get 2 points
Yes.
or no points?
Everybody raise your hand for 3 points.
Here's the deal, guy. There you go. Boom.
Funny.
I don't think you want.
I'll take the 2. I'll take the 2 points. I'll take the 2 points.
Can I try and shoot this?
Whoever's watching notes, I feel really bad for them right now.
Yeah. Okay. Good point. All right. So, what is the solution to these? Rewrite these. So here's where I was trying to make a point. Desmos might fuss with this, okay? Because it thinks there are calculators that do solve equations, right? So you can just you can put an equation in there, and it will solve it for you, like Papa Math or whatever it's called. Math Papa, right? There are calculators you can buy, but you're never allowed to use them on any test. So all we have to do is go y equals x squared plus 1 and y equals x plus 3. And we want to find where they intersect. Now, looking at this problem, what did I add to it? The y's. So don't give me an ordered pair answer, because the y is something I just made up to find a solution. The answer to this problem is what? X. The answer is going to be x equals something. Now, you might be going, wait, but you just give me an x, y here. Why is this one different? Brody.
You don't have to write the system.
I didn't make up the system, right? And what do you see in this question? Y. They want to know what's the x, what's the y to make this true. Down here, there's no y. I will take off points if you tell me what y is. I will take off points on this question if you tell me what y is, because there's no y in the question. Okay? That's like me asking a question and you say, I'm like, what's the value of x? And you say, x is 7 and a is 2 and b is 32 and c is 15. And I'm like, what?
But what if we just circle x?
Is there still 2 answers for x? Are there 2 x values?
Fundamental theorem of algebra says highest degree, how many we should look for. Okay? So we go to Desmos, and I'm going to plug these in. I got, we're just, Desmos is our,
No, they're boring.
on this one, yes, but Miss Walters does not like letting kids have calculators all the time.
That's what we should.
No,
Where you been, bro?
we just have different philosophies on that. Okay, so here's our solutions.
Did you ever argue with her?
With Miss Walters?
Yeah.
No,
No, about that.
no.
Then you can just give her a point.
We're pretty. Mr. Bolin the other day was giving me a hard time, and I'm like, that's a point, Mr. Bolin. And I walked away. That's a fake story. So what are my solutions to this problem?
-1 and -2.
-1 and x equals 2. Again, it's not an ordered pair solution. It is purely, I'm trying to find x, and I figured out this trick. This works for every equation. So in the future, when you're like, I need to solve this equation, you can use this trick. Again, unless it's asking you specifically, if it just says solve this system, you do it however you want. The next one, y equals. Actually, I'm going to show you a different method. The other method is called the zero method. So I'm just going to move everything to one side. I'm going to subtract 2. I'm going to add 0.5x, and I'm going to get negative 0.5x squared plus 0.5x plus 3 equals 0. So on the online homework for the test, for anything else we do this year, even though I've said like use these different methods, you totally get away with using Desmos, right? That's why I want you to do it. So this one, instead of doing at 0, I'm going to type in y equals. Again, I don't care what y is. I want to just figure out what x is. I only have one equation. Negative 0.5. Okay, and then what am I looking for here when I only have the one equation?
Your x-intercept.
My x-intercepts, because I've changed this problem. I think it's probably quicker just to throw them both in there, but this is another method. What are my solutions? 3 and negative 2. Okay. So, again, I'm trying. You would just take the roll over there? You think he's going to come back?
Just take the roll over there.
I swear. Okay, it's good.
Yeah. Good job, Jasper. Okay. Was that 4? Did you go back 4 times? 5? It was 5? Wow. All right, so this problem, again, it's just a mess of stuff. It says, what are the solutions to each equation? This is the only direction that you have to make sure is rewrite each equation as a system and graph and solve. So that means I have to write y equals absolute value of 5, or absolute value of x plus 5, and y equals negative 4x plus 8. Okay, and then we have to write, so on the homework, if you don't rewrite these, you'll lose easy points. Basically, the left side equals y equals, and the right side equals y equals. And then all we got to do is go to Desmos and type them in. How many solutions do we expect in B as in boy? 3. How many? Up to 3, right? How many solutions do we expect in this one? This one's a little trickier. It's actually 2, yeah. Why is it 2? Can someone tell me why it's 2? Is that?
Because of the absolute value for the negative or positive.
Yeah, so the absolute value is like a switch. It says, I don't care if it's positive or negative. It's not going to be the same number, potentially. It could, but it's just saying, I don't care. Okay, so we go to Desmos and we type this in. Have we ever typed in an absolute value?
No.
So I go to my y equals all of the thing, oh, right here, absolute value. Y equals absolute value of x plus 5. We never seen this, but it doesn't matter. There it is, right? And the other one is y equals negative 4x plus 8. So we get this solution here. X equals 0.6. Again, I don't care about y. Tell me why you think there's another solution or why you think there's not another solution. Eli. Doesn't look like it. I like that answer, but I want a little bit more.
A straight line.
Straight. They are both straight lines. It's getting further away.
The absolute value one is like it's like going farther out, and like the second one it's going out, but like slightly less out.
Sounds like people are singing. Yes.
It's like in one
Yes.
one's moving farther away.
I want very technical language if you can.
The slopes are different, so one slope is faster than the other.
The slopes are different. The slopes over here are different. Okay. If they're different, they will intersect, but they won't come closer to each other. Okay. So there's no reason for us to look for that other possible answer. Second one here, y equals x to the third. So how do I make this challenging? Because all I'm really doing is typing this in the calculator. Josh. By making you graph it yourself. Okay, I'm not going to do that, but yeah, that would be challenging. And we did that. We saw it by graphing systems a long time ago. What else? Say again. There'll be a little park away. Oh, Beulah Parkway. Okay. So this one, how did I make this more challenging?
It's like really condensed in the middle.
It's condensed in the middle. I'm going to go home here. That helped. The other way is I could make it so that other solution is way off the screen. Okay. So here's our three solutions. Boom, boom, boom. But yeah, if we were way off.
You just click on them. For me, it disappeared.
Yeah, they disappear if you like hover over them, and then, but I think if you click on them, they stay. X equals negative 3.225. X equals negative 2, and X equals negative 0.775. Fundamental theorem of algebra says there should be how many solutions? 3, and there they are. Yeah.
So they just show not all the time will there be that number of solutions.
Up to 3, yes. So there could be 0, 1, 2, or 3.
What for 4?
There could be 4, up to 4. Okay. That's what the fundamental theorem of algebra says. All right, so solve the system by graphing. Notice I left very little space. My first question, do I need to put the y? Is this a x, y answer?
Yes.
Yes. There's a y in the question. There better be a y in the answer. Down here, is there going to be a y in this answer? No. There's no y in the question, so there's no y in the answer. Okay? Any marks that go?